Okay, that's 5 after, so we'll go ahead and get started. Again, my name is Dan Kahn. Most of you know me. I was running CNCF for the previous 4 years and stepped down, although I still am leading a lot of our, or involved in a lot of our telecom efforts. I've now gone and launched a new effort called Linux Foundation Public Health, which some of you are actually involved in, and definitely appreciate that support. We just launched 2 weeks ago, prior to since our last meeting. So I will go ahead and put the URL in here just as a little plug. Feel free to take a look at some of the things that we're doing. We're very pleased. On Friday, Canada just launched their national app based on the code base COVID Shield, which we host. And Ireland has another app called COVID Green based on code based on a code base we're hosting. So we're expecting that to now come to many US states and a number of other countries as well. But that's my side gig, or this is, depending on your point of view. So let's turn it to telecoms. I did want to mention to welcome Tal Leron from Red Hat here. He and I have been speaking about Tosca and CNFs and such for I think a year now. And so I'm very interested to hear his presentation about TurnDot, and appreciate his provocatively titled, "Is it time to stop using Helm for packaging and instead standardize on Tosca?" which hopefully will get everybody's attention here, if not switched over by the end of the call. But I think we should kick it off with Taylor. If you could take us through for a few minutes, Taylor, particularly the updates around where the CNF conformance beta testing, how that progress has been going, and then also collaboration with CMTT, I think are going to be the key initial topics.
Sure, thanks, Dan. Okay, let's see, I kind of had it a little bit backwards on that for the collaboration first, but let me bring up.
Whichever you prefer, Taylor.
It's okay. Slides. So it might be, yeah, I guess I'll start with the community side. I have that, and then I'll bring up the other one. Specifically, it's probably interesting just to jump right in to this one. So there's a lot of different initiatives and communities. Probably could put in the TurnDot right here as far as implementations, but there's so many. So this is just a small snapshot looking at collaborations. Now, specifically, this slide deck, and I'll go back over it, is about collaborations around the workload and where requirements are coming from and how we're driving those and stuff. And there's been a lot of work on the within the CNTT RC2 work stream, and then how does that tie in with OVP's badging, and then how does that tie in with all the conformance testing from the CNF cloud native principles aspect that CNCF is doing in the CNF conformance program. So we got together, and this is just a slide deck that Oliver Smith, Frederick Kotz has also been working on this with us, and myself, to try to intro an effort that we've started around the workload specifically, so that we can try to group the different efforts to source as much of the requirements as possible while still giving autonomy for all the different groups. Because if you look at some of these, the RC2 is going to be using OPNFV testing and CNF conformance. It's also leveraging upstream end-to-end. So it has a lot of upstreams if you look at all of these. So we're one of the upstreams that we're trying to provide. And we want to try to help with this. And we're trying to make upstream sources available for all the different communities. Like the CNF testbed can be used as an upstream for the RI2 testing, just like some of the other testing pieces. And this particular effort is around the workload. So what we're hoping to do is get more communities to provide direct information about requirements. I've been actively seeking the requirements from different communities and trying to make those public. We have a large spreadsheet of covering a lot of the platform requirements that we thought would be good from cloud native principles that a platform could use. And we're trying to focus on a lot of that from the workload as a group, and looking at how OVP2 could use it for as one of the sources, and the platform as a service initiative, XGVela, and other ones that could use it. So these are some of the groups that we've been reaching out to, and I'm trying to reach out to everyone that's here on the Telecom user group, and reached out to some others as well. And what we have is a spreadsheet for we're starting as far as collaborating on it. That's this is linked in here, and I'll put this in the notes here in a minute. But we have a spreadsheet that we're building out all of the requirements, and then saying where do the source, if they come from, or any type of ideas. And then is this a principle? Is it some type of functional requirement if we look at like distinct network connections? But we have a walkthrough of what all of this is about. And then the communities and where we're referencing everything. The end result we're hoping is a set of requirements that then can be used back in those upstream projects to drive things. And then any test that we can say are already covering. So some of these we may say, oh, this is already covered by, it could be close enough on the integration between platform and workload that we may say, oh, there's a Kubernetes conformance test that covers that piece. Or another one may be the CNF conformance covers it, or whatever it may be. But the end result is to be able to use in the different projects and allow each one of those to go off and use them, remix and modify. So that's one specific area of collaboration we're doing. And we're having weekly calls tomorrow at Tuesday, if you'd like to get engaged on that. And I'll drop all this info here in the deck itself. I'm going to bring up as far as status on the, oops, that's the wrong one. On the CNF conformance itself, I'm trying to find the correct slide here with the, that's not it. CNF conformance itself, we've been working on the first set of platform tests based on input from many sources, including the reference architecture requirements from CMTT on the platform, but we've also been talking directly with operators and CNF developers, like, so that could be vendors, that could be developers on open source projects like Network Service Mesh. Together, what are the highest value ideas for test that we think are reasonable to implement for as far as platform testing. And here we go. So these are just to quickly reverse back. So here's the categories and the first set of workload tests, and the same categories that we're using, microservice compatibility, all the way through stuff like hardware resilience, where we're doing chaos testing. These are the same type of categories that we're using on workload. We're also using on platform. And this is that first set based on feedback that we're trying to implement. And this is partly who's currently active. We'd be happy to have other folks that would like to contribute directly to writing tests, or if you have ideas for new tests, but this is the first set that we're looking at. We have some that were about chaos and stuff within the containers and pods themselves and ensuring that the workloads continue. We're doing the same sort of stuff on the platform. So the idea here is to have a set that anyone could use, whether you're testing. If you're focused on the platform, you can run the platform test. If you want the workload, you can run the workload test, or you can run the whole suite if you have, if you desire. And then every individual test can be run by itself, as well as the entire categories, and that's across platform or workload. That's what's in progress right now, and currently the platform testing is focused on the CNF testbed is one of our reference target platforms that we have. We also can use kind. Many of the things can be done with kind, of course, as that's going to have some limits once we're into platform. It seems to work fine for workload, but the platform's going to have more limits. And the test suite itself primarily just needs a kube config to target. So we would like to have other platforms available. And so what we're going to produce is something similar to our CNF examples. We have a CNF examples documentation in the CNF conformance. What we'd like is some platform examples. So if anyone knows of any platforms that are available that would be good targets to run tests against, then we'd be happy to add those to the list of ones to check out. And then of course, it's the whole suite, the whole test suite is based on the Kubernetes conformance program, and specifically in that you can download and run it yourself. So there's extensive docs around that. And for those that did not see, or you weren't here last time, we got through with a beta test round, our first beta test round using the CNF conformance, took feedback on that and did a lot of improvements around getting started, making it easier, documentation, the usability on the CLI and stuff like that. So happy to answer any questions or comments if y'all have any, but that's probably an overview, quick overview of collaboration and where we are.
Yeah, hi Taylor, this is Sudeep Batra.
Hi, Sudeep.
Yeah, actually this is first time for me joining this meeting, so I see there's a lot of information. Is it possible to share the link of the slides that you have covered? It would be a good reference.
Yes, I'll add those links into the meeting notes.
Thank you.
Any other questions or comments? All right. I'm not sure who added the Kubernetes usage and telecommunication survey from it's a CNTT driven effort with an elephant.
Yeah, that was me. Hey, Taylor.
All right. Hey.
Yeah. So maybe I can just give a quick overview. So CMTT is, if you're not familiar with the effort, is designing reference architectures of how Kubernetes should be run in the telecom industry. And that was a little bit what you saw on the slide deck that Taylor was presenting earlier. And as a part of that, so I'm Bill Mulligan, and I'm the workstream lead for the reference conformance based on Kubernetes. And one thing that we're trying to do is to have a survey of how Kubernetes is being used right now in telecommunications. And so we're trying to survey the industry to see and kind of like track both the progress of the industry and the progress of our work against the industry, so we have a better understanding of what the actual progress is. And so the goal of this survey is to have feedback from operators and vendors of what their actual usage of Kubernetes is right now. So if anybody's on this call, it'd be great if you could help us by filling out the survey, and then we hope to repeat the survey on an annual basis and provide the results back to the community, so we have kind of a barometer of what the actual usage of Kubernetes and other cloud native technologies in the telecommunications space is. And this will be used to help inform the work that we're doing in CNTT in both the reference architecture and the reference conformance workstream. So please help us out by filling it out and passing it on to other operators that you work with. Also, if you have any questions, please feel free to reach out to me. My email is in the meeting notes.
Thanks, Bill. Tall,
Yeah.
you're up.
All right, excellent. So I wonder, I actually don't know how long this meeting usually goes. How long do you think I can take? Or who's the organizer?
20 minutes is fine. So if you want to take 10 or 15 to present it and then leave some time for questions, or we can interrupt as you're going.
Yeah, that sounds pretty good. So first of all, thank you, Dan, for the introduction. That was exactly right. You caught on the provocative statement pretty well. My intent was to provoke there, but yeah. Also, I want to apologize for some of you don't know me, and I just dropped in the meeting and parachuted in with a presentation. But it's a conversation I've been having with a few of you for a while. I usually like to have my ducks in a row before I present something, but I think the ducks are aligning, so it's a good time. I want to start actually by asking, there are 26 people here right now. I think I can ask this. Do any of you have any opinion about Tosca, or have you worked with Tosca? What's your impression of what Tosca is? I realize some of you never heard of it, but anybody want to pipe in with some non-judgmental, for me, impression? Okay, everybody's shy. So, Tosca has been around since 2014. It's a language that is supposed to be used for cloud orchestration. That was the intent. Started off in XML, moved very quickly to YAML, and is now at version 1.3. And a group of us are working on Tosca 2.0. I think, when I ask people about Tosca, a lot of the impression is they remember it from, it was supposed to be something like what heaped templates are in OpenStack. That is a declarative language that you can describe your resources, and it has topological knowledge. So it's basically a graph database. So you have nodes and you have edges between the nodes, right? Vertices and edges. And but people remember that it came with all these basic types. It was called the simple profile, that were meant to describe this abstract cloud infrastructure. And there were things like a compute node and a network relationship, a network node and relationships and data types, etc. I think that left a really bad taste in people's mouths. And when I ask people about Tosca today, they either say it's, I heard it described as a necessary evil. So people who work with ONAP and Etsy Mano, if you know, Etsy Mano embraced Tosca as a descriptor for network functions. So people who need to work with it find it a necessary evil. My opinion is that if Tosca didn't exist, we would have to invent it. There have been similar efforts to use the Yang language to start enhancing it and describe things, but Tosca has been around for a while and is designed to do exactly that. And part of what the team working on Tosca 2.0 right now is really trying to remove that kind of cruft that we had before. So one of the first things we did was actually remove the simple profile from Tosca. So Tosca from now on will be only a grammar. That is, it doesn't come with any base types to describe any specific cloud system. And what I'm going to show you today in the demo is that I built basically Kubernetes types for Tosca. And yeah, you know what? I think the best way for me, I didn't plan, I do have slides, but I thought for this group it would be better not to go by slides, but just to keep it an open conversation. So do feel free to interrupt me at any time. So I will share my screen if I can and just show you how it works. How Tosca on Kubernetes works specifically, because there are versions of Tosca using OpenStack and using BPMN kind of middleware solutions. Tosca can describe anything. It's an object-oriented language, so you can create your own types. And that's where it gets kind of similar to Kubernetes and custom resources.
Tal, I will answer your question, which is from earlier, which is reputation-wise, my impression is that Heat was always extremely closely tied to OpenStack. And so it was challenging to try and use a Heat template to describe a CNF on Kubernetes. And that Tosca was not that, and so was more portable, but had potentially the opposite problem of being so general purpose that it didn't necessarily describe it. And I guess I'm particularly curious or concerned about, well, if you eliminate the primitives, what is left? And I do think that just some examples would be the best way of trying to address that.
Yeah, I'll show you. I'll say briefly that Tosca does have some killer features that Kubernetes CRDs don't have. Kubernetes CRDs keep getting better, right? Right now, there's like the open API kind of data validation, right? If you look at the history of Kubernetes, we started off with specs. We added statuses, you know, status sub-resources, and we added data validation. You know, Kubernetes manifests are slowly growing up. They're still very, very far from what you get with Tosca. With Tosca, you have a very, very rich data validation system. It's very strictly typed language, object-oriented, so you can inherit types. And also you have the topology, which you have relationships between types. You know, when you build things like service meshes and things in Kubernetes, you know, we build them, but they're not, Kubernetes itself doesn't know about the relationships, right? We have selectors. We have other ways to do it in Kubernetes. And another killer feature is service composition, what I'm going to show you. Defining things that are multi-cluster, you can replace parts on demand. So if you have a network service and you need a certain network function, it can be taken from the inventory and replaced with something else. Once you're object-oriented, you have contracts, right, with a base type. So if you expect a certain base type to exist, you know, subclasses could implement it in different ways. I kind of wish Kubernetes was built on Tosca from the start. I think we're slowly moving towards it. That's why I say that if it didn't exist, we would invent it. We're slowly recreating the wheels of what Tosca is in Kubernetes right now, as far as I can tell. That's not a problem. You know, we can fill in the gap. Kubernetes is an extensible platform. And I'll show you an operator today that can bring Tosca to Kubernetes. So I might as well jump in. So I'll share my screen. All right, so I hope it's all big enough. So I sent on the agenda, you can see a link to this too. So yeah, instead of slideware, you can read the README page. I think it goes through a lot of what it is, but it's really, it is just an operator. It's a Kubernetes operator, and but what it's meant to do is consume Tosca packages and orchestrate them on Kubernetes, turn them into Kubernetes workloads. And what's interesting about the workloads, they are integrated. It uses annotations. So it's kind of, if you use Helm, you know, you deploy something with Helm, you can delete that whole deployment with Helm, right? So the language in Tosca is called service template. So what you deploy with Tosca is a service, right? But it can be an application, it can be any other workload. What I'm trying to show you today is the example of a telco workload specifically. So yes, I work specifically, so I'm, quick introduction, my name is Tal. I'm from Red Hat's CTO office, and specifically the networking group, right? So this is, telco is behind all this, really. Telco is the example of Kubernetes workloads that I think are some of the most complex, because they're always very heterogeneous. You always deal with black boxes, right, that come from various vendors that have their own vertical stacks. You deal with VNFMs, sometimes entire orchestration systems that come with the products. So you end up having to stitch together a lot of things that are very different. And it's often very hard, right? You have big projects like ONAP trying to herd the cats, so to speak. But a lingua franca like Tosca is a great way, I think, to model the various parts you have and able to delegate to those other orchestration systems if you need to, via Kubernetes operators, or sometimes just API calls to an orchestrator running elsewhere if that's what needs to be the case. So the example I'm going to show you today is a multi-cluster network service, specifically telephony. So there's a central cluster. There's an edge cluster. Each one is running the Asterisk PBX. One of them is running it in as a VNF using KubeVirt. The other is the smaller edge cluster is going to run it as a container, the CNF. Multis is being used to create a data plane between them, actually that goes through a PNF, an external router. So that can also be orchestrated basically using netconf. And yeah, so in the end, we have the control plane that is the standard Kubernetes. Then we have the data plane, which is a second interface. I'm putting WAN in quotation mark because I'm running this all on one machine right now for a demo. And you can have SIP phones that connect to each of them and can call each other, and that goes through the SIP trunk that goes over the WAN. So let's see how that's implemented. So I'll look at the Csar packages. So each one of these things is Csar. So Csar stands for Cloud Service Archive. And that is a Tosca definition. It's very, very light. It's basically a zip file that has this manifest. It's inspired a little bit by Java jars. It's not too interesting. What's interesting is this YAML file that is the actual Tosca definition. So I want to start from the top down. This is the network service that I want to deploy as a whole. And yeah, you know, if you know your YAML, some of this would be familiar. But then, you know, this is the Tosca language. So we have a topology template, which is everything, this whole service. And then we have a bunch of node templates. And this looks very abstract. They each have a type. So this is a PBX type, which is a base type. And there are other things that inherit from it. And here I'm defining very generally what I want. I want certain capabilities. I want to create a trunk. This is the type of the node. I'm creating a few endpoints here just automatically for testing. So these are phone numbers, 200 and 201 with a user and password. Obviously, you would probably want to connect this in deployment to in production to a real database, but this is an easy way to generate them. And then I have requirements that create the topology. So this needs to connect to a data plane, which is its own node. And also there's a trunk that runs on that. And it wants to connect to the edge. So this is the central PBX. Here's the edge PBX. It's very, very similar. It's just the opposite way. In no case did I say that this should be a VNF or this is a CNF yet. How I do that is by policy. So policies are ways to give hints to the orchestrator to tell it what I want to do. In this case, this is a provisioning policy. And I can tell it which site I want it to run. So there are these function calls. And I can also give it substitution input. So this is a little bit technical here for Tosca, but the way Tosca does service composition is by substitution. So these nodes can be substituted by entire workloads that implement that same PBX. So in this case, I'm going to substitute it with a VNF that is much more complex. It has a database, it uses KubeVirt. In this case, it's a self-contained CNF. But I decide which one it's going to be according to policy. And there's an inventory, and I'll show you how I register things in inventory where these can be placed. So I'll move a little bit quickly here. I don't want to take too much time on this. I want to show you, let's look at the CNF because I think it's simpler and maybe more interesting. So the CNF is defined using, so here I import various kind of profiles into the Tosca. And one of them is the Kubernetes profile. And the Kubernetes profile will look a lot like Kubernetes manifest that you already know. So there's the Kubernetes metadata. There's the deployment. UDP here is defined as a service. So this is a load balancer just inherits the Kubernetes service, and it's of the load balancer type. So we have ports. We have ingress attributes. So attribute is what we call in Tosca. That's basically the status sub-resource in Kubernetes. You know, runtime attributes that change. Properties are the things that tend to not change. So a lot of this, you know, if you know Kubernetes manifest, it's almost the same. You see the difference here. There's some Tosca function calls. But this is a way to package together. And yeah, excuse me, this is not a really great implementation of RTP tunneling, but this is for the demo, I think this will work. What's interesting here is the artifacts that get connected to it and this interface. So for the configuration phase, you know, once this is installed and running, there's cloud native configuration. That is, the service can orchestrate itself using a script in this case. So, and all these artifacts that are attached to it. So if I look back to the Csar file, you'll see I created this artifact subdirectories here, and there is, actually, this is interesting. There's a tarball here that I included of the entire container image. Now, I don't have to do that. You know, when you create a deployment, you know, you give a container, you give the image, and it can just be a URL on some Docker repository. In this case, I'm using the get artifact function to actually take the artifact that I'm attaching here in the Csar file. So I don't have to do this, but I can package the CNF container image in that zip file with it, and TurnDot will be able to upload that automatically to its inventory. So this is a way to have kind of a self-contained network function, right? You can have everything you need for the network function in a single file. So that's useful. And of course, there are other artifacts that are the scripts. So if I look, for example, at the script, oops. So there are scripts, for example, for configuring the network function here. So yeah, it's a bash script. It's not too interesting, but it does some, it takes various templates and creates the configuration files for Asterisk according to various inputs that it gets and takes from the Tosca. So how does it all work? So I'll show you. I have the two clusters running. So here's the central cluster. And this one is the big one. It has a lot more memory. It has KubeVirt. The edge cluster doesn't have KubeVirt. It's a bit smaller. So I will show you first. I have a little cheat sheet here. I will first install TurnDot on the central workspace. And the TurnDot command line is you can do everything with kubectl, but the TurnDot tool, just like many other tools like istio.ctl and home, these command lines that just make it much easier to work instead of using the CRDs. So it installed itself. And if I go back, I'll see there should be a workspace. So we have, oh, sorry, that's the edge. So we have, so here it is. We have the TurnDot operator, and we have the TurnDot inventory running separately. In this case, it's just a Docker, the default Docker repository, but this could be something much more big. Any kind of Docker repository could work. So it could be Quay, it could be Harbor. All right, so that's installed here. Now I'm going to register. Okay, there's a hello world. We'll ignore. We'll jump right to this. So I'm going to register. First of all, we're going to set a delegate. Okay, so the delegate is interesting. The delegate is a way. Oh, okay. I want to change to set the default. Oops. So I'll work on the central cluster. And then I'm going to register a delegate. What the delegate does is connects the central cluster to the edge cluster. So now the edge cluster, the central cluster knows how to use Kubernetes client certificate to actually connect to the edge cluster. And now I'm going to register on the inventory all the Csars that I had. So I'm just going to, every time this happens, they're basically uploaded. This template register uploads that Csar file and gives it a name. So if I do TurnDot template list, oops, it has all of them. And right now they have no services deployed with anything. And now I'm actually going to deploy the network service with a single command. And what it does is it uses the template that I already registered and gives it an input. I tell it which namespace I want to work in. And I'm going to do a watch. So what this watch does, it does a service list. And we're going to see what happens here. So we have the telephony network service was instantiated. And immediately it substituted using the policy, the Asterisk VNF for it. And we also have the simple data plane that was created using Malta CNI. So it already, these are the inputs that are coming in. So these are this has already been instantiated. This is still instantiating. So the KubeVirt does take a while to start. It's starting a whole virtual machine. But I will show you what we see. So for now, it's not up yet. It does take a while. But on the edge site, we have the Asterisk. So first of all, TurnDot installed itself on the edge cluster. So it was able to do that. And once it was installed there, it could delegate workloads to it. So we have the CNF already running. It's pods, everything is already running there. And here we have the complicated UDP service that tunnels the SIP phones. And the inventory is where it was registered. Oh, I think I saw a change here. So this was instantiated. We don't yet have the outputs. So it still trying to configure itself. And another interesting thing about configuration, they have access, because this whole workload is one whole thing. When the Asterisk VNF needs to be configured, it is able to access data from the rest, right? So it knows that it's part of a service. So if it needs to connect to the data plane and needs to know what the address is, it can ask it directly. It's just there in the data. It doesn't need to call an API. It's just there in the custom resource. And I'll show you how the custom resources actually look. So if we go to custom resource definitions, so you can see service. This is the custom resource created by TurnDot. There's a lot of other stuff here for KubeVirt. And you can see these are the 3 services that were deployed. If you look at the VNF, so I'll show you the VNF right now. Oops. Right, so here are the outputs that came up. So, you could use the basic Kubernetes API server to access any of these. So everybody always has access to the rest of the workload. So I want to actually connect phones right now. I think I am out of time too, but I can connect phones to both of these PBXs and make phone calls between them. You know, maybe just I'll very quickly just show that it works. One phone. Yeah, so it did work in terms of registration on the SIP was connected. So I'm using LinPhone, a software SIP phone. And let's just call 911. Am I getting something? Yeah, nobody, I'm talking to myself here. Okay, so, but it did register. So that is what I wanted to show you. I was really hoping to discuss what the implications of this could be, because if you think of what I showed you here, I think this is very close to the kind of a service composition that we're looking to do with network services, right? When we look specifically on cloud native and Kubernetes, right? We want to be able to compose services using network functions registered on inventories, using network services registers on inventory too. If you notice, they were both there. The difference between the layers was not, they were just implemented in different ways, but they were all speaking Tosca in this case, right? I'll mention too that there is support here for Helm. So Helm can be attached as an artifact. So if I'll show you a quick example.
Tal, I was hoping you could maybe spend a few more minutes on that, which is, and by the way, this is a great demo and way more impressive than just showing slides. But if you're not interested in having a comparable service running on OpenStack, if you're just focused on deploying a set of service compositions onto Kubernetes, could you please speak to how you see the value of TurnDot versus doing it in Helm?
Yeah, so I didn't do anything here with OpenStack, right? This was 100% Kubernetes.
Right.
Yeah.
Well, yeah, your previous slide a second ago was showing TurnDot playing a similar role with VNFs or with CNFs. But go ahead.
Yeah. So so I'll say this: the Helm. I think I'll show you actually. There is a FAQ about that. So it's this is a new project, so it's the FAQ is not a real frequently asked question. These are questions I ask myself, but I'm answering them for you. Oh, I should say something else here. I'm from Red Hat. I presented myself as from Red Hat. This is not an official Red Hat product. It's not on any kind of roadmap. This is something that some guy at Red Hat is working on to try to solve problems. So keep that in mind too. But here it is. Okay, so why use Tosca and Csars instead of packaged Helm charts? So this is where I get very provocative. The fact that Helm became really standardized, even though there are many efforts to create packaging formats for Kubernetes. I'm sure some of you tried some of them. And we all kind of aligned on Helm to an extent because it was the most neutral. Helm just takes, at its core, Helm takes Jinja-like templates and turns them into Kubernetes manifests. But for the most part too, Helm is pretty dumb about it. It's just text files and it just do text templating. I think that has not served us well. Text templating is one of the worst ways to generate YAML. YAML is a language that is based around indentation. And in any case, it's not validated at all, right? Until you actually render the text template into YAML, you don't know if it's really there. Now, the parallel effort in Kubernetes, as I talked about, was to CRDs have become much smarter, right? There's the last few versions of Kubernetes had the Open API version 3 validation schema, right? So you can actually give schemas to things. So that's a big step forward. But Tosca is very strictly typed from the beginning. So the Tosca code that I showed you, if you make any kind of mistake here in terms of type, or all the properties have their own types, it won't compile. You would get a very clear message of, you know, what went wrong and at what line. So this is a strictly typed language, strictly typed object-oriented language. So that's a huge difference from where Helm is. And
okay, so that's that right there is a clear distinction. I'm curious if you played with customize with a K
yes,
as one of the Helm alternatives.
Right. So customize is kind of like a Helm light, I would call it.
Well, so my suggestion to you would be that it would probably be worthwhile to flesh this out a little bit more in your FAQ, and you can treat it as one of your first initial external questions that you're asking. But
Yeah,
maybe even coming up with a table that said, you know, here are packaging solutions for CNFs and features that you might want for them. And of course, the TurnDot would have checks all the way down.
So I apologize, and I got a question as well, if you don't mind. So one of the things that I've been looking at from the enterprise side, so we know that Helm has significant drawbacks, and you stated them very well. One of the ways that we've gotten around some of those problems is not using Helm in isolation, but using something like Terraform on top in order to drive and create the Helm templates and to parameterize them properly and then deliver that. And so in terms of Terraform with Helm and TurnDot Helm, do you think you'd see privilege, or do you think you would see improvements by moving over to the configuration stuff to TurnDot instead of just having like Terraform itself call Helm directly?
So Terraform is obviously a very mature product, so you get a lot of other things with it. But it's also external. I think TurnDot is an operator, right? It's not running outside the cluster. It's a very small executable when it comes down to it. So it just runs in a very small container. Not a problem to run it on the edge. As you saw in my demo, you know, the edge cluster had its own version running. So there's nothing external here. Terraform will have to be set up as an orchestrator, right? Outside, it could run in the cluster, right? But it is an orchestrator. TurnDot is not exactly an orchestrator, right? It extends Kubernetes native orchestration ability. So I think that's a more forward-looking cloud-native approach, I would say. But of course, I'm biased here.
I get it, and I think there's a possibility for the three of them to work together as well. Like you could have Terraform create and parameterize the initial TurnDot, and then use TurnDot at that point within a individual cluster as an option. So I'm trying to understand some of the positioning. So this helps.
I think you're exactly right. You know, there's a kind of Unix philosophy going on right here that I'm not trying to solve all the problems. What TurnDot specifically is trying to do is bring Tosca to Kubernetes. Now, where the Tosca comes from, how you generate it, how you design and model everything is left up to you, and an external service can do that. You know, if you know products like Cloudify is a whole orchestrator based around a Tosca-like dialect, right? But it runs outside, it has a workflow engine, it can do other things. TurnDot has no workflow engine, right? It doesn't try to do workflows, right? I think workflows are, you know, if you want to use, for example, Argo workflows, I have been starting to work with a profile for Argo for Tosca. So you would be able to define Argo workflows using Tosca as well and just import them into your service template if that's the way you want to go. But yeah, this is very Kubernetes native. That's the intent. And you know, two other, I think, the big features that differentiate from Helm. So one of them is, of course, as I said, the grammar itself. This is a strictly typed, object-oriented language. But it's also the service composition, I think, is another killer feature. The idea that you can define types abstractly and have them substituted from the inventory by policy, right? Yeah, I diverge here a little bit, but if some of you've seen some of my talks at ONES, I talk a lot about how the future of orchestration is really policy oriented, right? We're moving more and more towards policies. But we're seeing more of that in the cloud native world and in Kubernetes as well. So policies are really key here, right? They are hints for the orchestration to tell you what you hope to get, right? And then those different policies are compiled together and distilled into a final decision that's made. Sometimes that decision is made by machine learning, right? Because the policies give you the guidelines, the limitations, but for example, in the policy here, I said that I wanted that one of the edge cluster was very small. So that means that it needs to fit a small PBX. Now, my inventory might have several of them, and the final decision might have to do with runtime data being, what is the throughput needed at that edge cluster right now, right? What if there's this edge cluster is near a football stadium and people are using their 5G phones to connect, and I want to deploy something very quickly? The AI can choose according to runtime characteristics which package and how to configure it, right? So that substitution can happen. Once it's policy-based, the things that implement the policies could be more intelligent than we are, right? AIs.
Sorry, can I have a question about the profiles and the like being object oriented? So you mentioned that Tosca doesn't have this simple profile anymore in its 2.0 version, but I think one of the big problems what we will run into with using operators and Helm is that none of these are standardized in any sense. So like everybody is now having their own great ideas how their CRDs should be structured and how to implement these CRDs, but all of these are different ideas. So is there any way in using Tosca and or TurnDot to solve these problems somehow? I'm not saying that we should have profiles again, but
yeah,
any good ideas to do that?
Yeah, I think you're really pointing to a growing problem that we're seeing, right? The explosion of CRDs and operators, and let me tell you too, a secondary problem. It's very hard to create operators. I think we have a long way to go before those become easier to create, even with the operator SDK.
Yeah, can I recommend the new CNCF sandbox project that
Yes.
folks from Red Hat may have heard of, called Operator Framework,
Yeah,
which
yeah.
is Red Hat kindly contributed last month. But I think we can agree that it definitely makes it easier to create an operator than starting from scratch, but definitely does not fall into the easy category. And but I would really sort of jump up and down and take the industry by the lapels and say, I'm not certain that operator framework is going to be the kind of winning or most ubiquitous way of deploying operators, but I think the operator pattern on Kubernetes absolutely is the future of telecoms. That the idea of trying to get away from having this PDF playbook that you're sharing with the operations team and saying, no, we can actually encode most of that into software and have our applications just be smarter and update themselves and optimize themselves, all those things over time using the Kubernetes CRD patterns, I think is incredibly powerful insight.
Yes, but I would go even
ahead,
further. So if it would be possible to have these CRDs somehow harmonized, so all of the vendors CNFs would have the same CRDs with the same parameters, that would be even better.
Right.
It's possible, but I will point out that it's not strictly necessary, that there's nothing particularly stopping you if you have 20 CNFs running in a Kubernetes cluster from having 20 CRDs that are orchestrating them.
Except if you would like to do some automation on top of that.
Yeah, so it's that composition issue. Last words, Tal, because we're out of time.
Absolutely. So two last
Where
words.
can we where can we reach you for more or to chat more about TurnDot?
Oh, so I'll put my email somewhere. I'll put it on the agenda if that's fine. And I think it's already there. But yeah, this is all, of course, open source. So the link is also on the agenda. So it's just on GitHub. So you're definitely welcome to play with it there. I did want to say, concerning operators, the big thing that I keep trying to say here that in the etc language, there's the Vim. And Kubernetes is not a Vim. Kubernetes plus operators equals an orchestration platform. That's the big point that keeps trying to be made here. Tosca it helps us to model it. In terms of standards, etc, of course, has this Tosca profile for NFE, which still goes by a Tosca 1.3. So, Tosca 2.0 hasn't been released quite yet. But yeah, I'll echo Dan. Whether that's a good idea or not, I think it's up to the industry to decide. I will say that I was talking to one telco a few days ago who was using Tosca internally, and they created all their own models. It was very easy for them to take those models and connect it to their orchestrators. They are using Cloudify to make that connection for them, right? So they did have to write code. They had to create the models in Tosca, so it's just knowing the YAML Tosca language. And they did have to know some Python to create the connectivity, the glue that connects between those models and the implementations. And yeah, there is some work to be done. Integration will never disappear. The idea is just to make it easier. and I do think Tosca is a step forward. As I said, if it didn't exist, we would have to invent it.
Okay, well, let's stop there. Thanks, everybody, for the call. We are going to be on the Slack if you want to chat more about this, and Tal can come on as well. And then our next call is a month from now at a more Chinese-friendly time, Asia-friendly time. Goodbye.
We didn't get to Sudeep's talk here. Maybe next time we can do that if you're available.
Sudeep, but yeah, we'll put you on the top of the agenda for next time. I'm sorry we ran over.
Yeah, that's okay. Thank you, Dan. Yeah, I can talk over next time. Basically, I mean, it's more like a query I was trying to ask, like, if we have these best practices towards deployment of multi-tenancy in, if it already exists, and as we are in the process of deploying, maybe we can, give some suggestions and add inputs to that. So that was basically the question.
Great. Okay, we'll look forward to talking about it next time. Thank you, everyone.
Thank you.
Okay.
Bye-bye.